So in the second half of this presentation, you're going to hear from Ron Grossinger, who is the Green Automotive Technology teacher at Memorial High School in West New York. Ron's been teaching there for over 8 years now, and he and his students have created some amazing projects, including multiple electric cars. Ron is not only going to share his experience and the success, but also talk a lot about the process that he went through and some of the errors and the mistakes that he learned along the way.
Out of the 8 years I've been teaching, I was, I think, teaching wrong, or not in the best possible way, for 7 of those 8 years. And I got some pretty good results. You can faintly see we built some electric cars. But all my open-ended projects, like kind of what we just did here, were by chance. And so I started noticing amazing results. Like kids would come up to me with the result of a problem-solving piece that I just didn't have time for. And it was much better than my solution. So once I started seeing this trend, I incorporated that a lot more. Let me just go over the slides, and then you can kind of see. This is a computer where they use SolidWorks. It's like a CAD program. So the student using this, I gave minimal instruction to. There's some basics they went through, and that's something I want to talk to Todd about. Because I'll be honest, I know Todd a while. Today blew my mind. I didn't really think that you could teach the basics with the open-ended way, with the creative process. But now I think you could. So I want to try that from the beginning. I was laying down the basics. So once I laid down the basics with this student, the design of the car, where all the components were to go was completely up to them. There is a set chassis dimension, but where those components, where the electric, where the computer, where the batteries are going to go, where the drivetrain is going to go, that was all open-ended. Let me see the next slide. Okay, so one of the components they're building is, this is the frame of the car, is that the A-arms, they have like a limit, that we know that how long they can be. But forward back is really, forward back, up down, the shape of them, all this was up to the student. And so this student right here, he's the one who did the CAD drawing first. I just gave him, I said, okay, well, just like you had, okay, 3 lights and it's got to have a battery pack or whatever it was. And I said to the student, I said, it's got to go like this, and the dimension has to be the same on both sides. So this is, this student on their own. Now, the only reason that happened was because I didn't have the time to design that A-arm. And A-arm is really, just think about your arms. A car is like a person in a way. So that happened by chance. Now, the other students, I'll give you an example of another student. Go to the next slide first. Okay. Another student had a set of instructions. You guys looked at the circuit and thought, whoa, this circuit. Can you imagine the circuit for an electric car? This is like extremely complicated. There's a lot of what I would consider gates, and if this, then that. There's some logic to it. The key's got to be in. The throttle has to do something. What makes it shut off, fail safely? So these are things. So, but there's a list of instructions. There's a wiring diagram, and the student, this girl, she's like 5'0". She's able to organize this. Let me see the next slide. There she is. She's able to organize this diagram and make it work. Okay? And I would go and check some things. But she can check a circuit with the voltmeter, and she can also see that it's working. You can turn the car on and off. But if you take these 2 cases, she has graduated, so has the other kid. When they both graduated, one of them, she's floundering. Although I think she's extremely capable, she built 2 wiring setups for 2 electric cars over the course of her career with me. She now works in catering. This is not that catering's bad. If you want to own the business, fine, but she does not want to work there. This is someone who's capable of building an electric car, but not capable of finding her career path. It's because, I think, because she had a set of instructions and she was a good student with me, because we vibed, where she didn't do well with other teachers and whatnot. So now the other student, the one who designed the system himself, I left him alone with the computer. that person now has aggressively pursued a career in design. So they, on his own, purchased the student copy of that program on his own, found out what it takes to be a professional and to charge money for this process, took this, there's a professional, it's a standardized test, but it's for professionals, and that's the basic one. Now he's going to take the advanced, going to college for design. So this is someone who's, you know, at minimal input. So this is kind of the thing. Now, so what I want to do is have less of it be about chance. Oh, I didn't have time to design it for the students, so that's why they did so well. I want it to be, I want to work with these lessons and do a thing where I design it so that they're aggressively and hungry, looking for more, and there's no end to the project, you know. So that's basically it. So we went from this to the last slide is this. It's hard to see, but it was Thomas Edison Foundation funded part of it, and the car, we got it to the New York Auto Show. Just one more note. The New York Auto Show, how do you get your car in the New York Auto Show, right? Because I didn't have time, one of the students said, she said, okay, I want to, can we get this in an auto show? And I was like, I don't know, you know, whatever you can do is fine. She calls the New York Auto Show. Completely naive, right? Amazing. You know, I mean, it's just like, you know, so I would be, okay, let's call the local place. She calls the New York Auto Show, gets us into the show by writing letters back and forth. She's correspondent. She just graduated. What do you think she does now? She aggressively pursued FIT for marketing, and she aggressively pursued a job where she can do something like that. She worked at the mayor's office after school, doing PR. This is what she wants to do. I let her do it. I got out of her way, and it worked, you know. So anyway, yeah. So that's basically it. There's the thing, you know.
Is that at the auto show?
This is at the auto show, and this is how many students are involved. But there's really only a handful here that actually got, I think, something out of it. And I'm admitting that. And you have, this is almost like, you know, this is like a full or almost 2 classes worth of people. And she's the one who called the auto show. She helped design the model for the A-arms. And it's hard to see, but I don't know where he is. But the other student designed the A-arms. So it's only like maybe like 2-3 people that really got something out of this enormous project. And I'm willing to admit that because I threw myself in this. But there was I gave a lot of instructions, and that did not work. Making someone follow a minimum requirement, it really didn't produce, in hindsight, the result that I was looking for.
And that right there, that's about the size of his physical shop, too, in that picture as well. So if you could imagine all those kids in that area trying to build a car around it, too, it's pretty impressive. He doesn't have that much space. Look at him that.
This room's about it.
Yeah.
It's long-wise. Yeah, it's not a proper shop.
No.
But, you know, whatever.
It's amazing
Yeah.
what you can do with it.
So
Ron brought up some good points, and I hope that we can think about those while we kind of design for it, right? So we're used to this. What do we really want to get out, and how do we actually create for that? So before we do design, I wanted to just run through some quick preview. We looked at 2 examples, traditional methods, which the 2 group kind of followed through with the directions, and the other one was an actual process-based learning with a product or a project at the end of it. So we said the first one, teacher instruction driven. We're looking for something that's design or inquiry driven, something that motivates them, something that engages them to ask questions. Highly structured, the question came up during lunchtime that Veronica and I were talking about. It takes a lot of time to design these things. It took a lot longer to sit there and write out every single instruction than it did to say rave party, Hurricane Sandy, or festive party, right? That didn't take that long. So the other one is open-ended, right? What is each person going to get out of it? The idea of an open-ended, what's the purpose of that? What happens if you have it highly structured and it's closed-ended? What happens at the end of it?
They're finished.
They're finished. They're done, right? Open-ended, they might have completed it because it's time is up, but they're still thinking about it, or they still know that they can improve it somehow. So that's summative, in other words, product-driven. we said that this is process-driven. We're looking at what the students are doing all along the entire process of it. There's a defined outcome we just said is bad. The other ones, everybody's different. And errors are encouraged. It's okay to make a mistake. We're not saying go out and definitely do this incorrectly, but it's okay to make a mistake. It's what you do after that mistake that defines your character. Thematic and narrow. In other words, they're focused only on getting them to do this one particular thing, whereas the other ones are integrated. So they're doing multiple cross-content areas plus connecting with the community of some sort. The traditional methods may be fun, but the project-based learning is fun and engaging. There's a big difference between having fun and having something that's being really engaging, that's that's pulling you in and drawing you towards it. Traditional methods were answer giving. We want things that are problem solving. Decontextualized, in other words, school worlds, stays inside of your classroom, whereas the real world brings some context of it outside. If you can do something that will live outside of your classroom, students will work harder. In other words, project-based learning inspires innovation and creativity while also motivating the students to want to learn more. It gives them that drive, if designed appropriately. So we've heard about design, right? Who's the person that does design? Sorry, who's the guru of curriculum design for New Jersey and writes the books on it?
Oh, Danielson? No.
Danielson does the evaluation and stuff,
yeah.
right?
So,
Understanding by Design, you've heard of that? UBD, right? Grant Wiggins and Jay Mateague. Yeah? Okay, so there's that, and then there's Richard Covey, and they both said, in the beginning, there was the end, right? That's what they always go for. And it was all understood by design. They look at this thing called backwards design. That's their whole mantra. So we're just going to summarize that and said, start with the end in mind. What is the end? That's the hardest part of designing a lesson. What is it that you want to get out of this? Think about that for a very long time, because that's going to guide you as you go through every single step. As you answer your students' questions or as you ask them questions, this should be in your head. What do I really want to get out of, what do I want them to get out of this? So let's take a look at some examples, right? If we think that in the end, they're going to know how to install an HVAC system, that's our goal. That's what we want. So what do? What's the process to get there? We put all of these HVAC system units into place, their training systems, so one student or a couple students works here, another one works there, and you have the next one and so on and so forth, right? In the end, what can they do? They can install an HVAC system because they did it over and over and again. They worked on that system. But they can't really adapt or problem solve because they might have been following through with some directions. Maybe you had some troubleshooting areas which the trainers are designed for. So you can like create a problem that they now have to find, right? What motivation do they really have for that though? What is the driving force behind that? That trainer may not be the best one for it. What happens when we switch systems? What then? The original HVAC system was a fireplace, right? Then you have these electromechanical systems. Now you have digital semiconductor materials or microprocessors that are controlling all of this. What happens as that evolves? Do you want to teach them how to install this or give them the desire to want to install it for a purpose and to be able to install anything else? What happens if they see an older unit? Then what happens? Can they solve that problem? Can they troubleshoot it? In the end, we want them to do well in a test because I know a lot of people say, oh, at the end of my class, whatever, they have a standardized test that they have to take. So what do? We design around that concept. We make them sit in rows. We make them take a lot of tests. We get them used to that idea of taking a test. And what do we end up with? They do well on the tests, hopefully, cross your fingers, because that doesn't usually happen. And they all end up being good students because I don't know about you, but I know very few friends that go out and have to take a multiple choice test for any reason in their jobs or their careers. And very few times they actually have to take a test of any sort. It's more of a procedural, evaluative method that they're watched day in and day out over the course of time. They get an oral or written feedback about their progress, not a number grade. So what is it that we're going to be doing after they get out of there, right? They're at school. We do all those things. We make good students. Check. The end. That's not what we're trying to do, though, right? There's a lot more to it. These are all areas that students are going to end up utilizing throughout the rest of their life in some way. If we design for these, if we design for creativity and innovation, for effective communication, for the use of technology and multimedia literacy, allow them to use their cell phones, encourage it, let them go in, because that's their lives. That's the life that they're living in. If we let them do that, and we teach them and guide them how to do that effectively, as opposed to just saying, here's a cell phone. We as teachers and mature professionals, we're not going to teach you how to use that appropriately. We think that if we just ignore it, you're going to be able to figure out all by yourself with your cohort of 6th, 7th, 8th, 9th, 10th, 11th graders that you're around, and look at how many times you hear about ridiculous uses of Facebook or Twitter or whatever on the news. Teach them how to use that responsibly. Incorporate that into there. It will be the thing that sets them apart in the end. We want intellectual abilities that extend beyond the class. That's the point. That's what you design for. Okay? So how does that work? Here's some advice for you. First thing is, model everything that you want in your design. Be as creative as possible. I thought of a rave party. Kids might look at that and laugh at it for a second. They might think, oh, that's cool. He actually knows what a rave is. Or the fact that they're dealing with something realistic like Sandy that just happened, right? So be as creative as possible in your own work. So they'll see that. They'll want to build off that. Trust that students are capable. That's one of the biggest challenges of teaching, is that we think that we have to teach as we were taught. So we were taught, somebody stands in front of the class and gives us information, and everybody's happy. When I was in high school, the internet was the verge of coming out, and you didn't even want to use it because it took 20 minutes to open up a website, and it made weird noises. Now, they get access to it at the tap of a finger. So we don't want to say that we're only capable of giving them information. They're capable of finding that information. So what is our job then? Not to provide them with stuff. It's to ensure that they know that they're capable and that we give them the opportunity to be capable. And shop teachers, this saves you a lot of time too. When somebody walks up to you and says, where are the scissors? Where are this? Where's that? And they haven't looked for it yet. They just think that the only way of solving that very simple problem is to ask you. Whereas if they knew that they were capable, they wouldn't ask you those questions. They would go over and they would get the stuff. So you can see in the design group, you guys all had to go up and get your stuff. You didn't have pre-cut wires. You had to learn how to use the tools. You had to learn how to use the meters. You guys had alligator clip wires. You didn't have to learn, you didn't have to get up. You didn't have to go anywhere. Sometimes I leave a wire out of those kits. Guess what they ask? Can I have a wire? They don't feel empowered to get up and go get a wire themselves because everything else was given to them. So trust that they are capable, and that's going to be really useful to them in the future. And make it real. Don't try to hide it inside of your classroom. Don't try to make it so it's only a grade that they're getting. You're all doing something that's called career and technical education because it's a real life thing. There are careers out there in the real world. So make it as real as possible. Bring people in from the outside. Send your work out somewhere. Advice for what to design for, or what to include in your design. Start with the 21st century skills. That's 9.1 on the state standards. Look at all the ones that were just listed before. Integrate whatever your content area is into that as a secondary part. So you're thinking, how can I get them to think creatively using the content of my CTE area? And then if you can, it's not always possible, throw in some of that Common Core. But the math is pretty easy in a lot of cases. English and language arts, a little bit different. There is scientific and technical parts, but if you ask me, some of it's not even relative to science or technology in the first place, especially if we're not trying to get them to figure out their own information. So, ready? Some more time for it. So let me just walk you through really quick how that circuit activity was designed. these are the areas that I wanted to get. And these correlate, if you can kind of see the underlined words, they correlate with the words that are on the bottom of your quality survey. So if you take a look at your quality surveys, I think it's 18 to 21, 16 to 21, 15 to 21. 15 to 21 has bold-faced words in it, right? So you're going to see words like question, infer, justify, evaluate, communicate, things like that. Now, how many people thought that their design project actually asked them to question, make inferences, collaborate, communicate, and do all those things? In other words, how many people had 4 or 5 for those?
I had a couple.
What's that?
I had a couple.
You had a couple? So there's 2 things that I think could happen here. Either I designed that like really poorly, or potentially we're not all course understanding what these words mean. It could be either one, which brings me to another point. When we say creative thinking, when we say inferences, we have to be on the same page as designers as to what that means. So define creativity as a collaborative effort with your school, and that'll be very useful. So that way, when I say collaboration, and I say my students were collaborating today, it means the same thing as what the science teacher down the hall or the math teacher up at the other end of the halls are saying when they said my students collaborated today. That's a very important piece of this. So that's something we can't do here, but your communities should do. So to give you an idea of where these words came from, these are what's known as key intellectual abilities, which are things that Understanding by Design, and Grant Wiggins in particular, likes to incorporate or does incorporate when he designs it. When you do a school-wide curriculum, you create your key intellectual abilities for the school. So things like questioning, inferring, discerning, justifying, communicating, those words are going to be defined by the whole school and then utilized in every class. So the students in my class are going to be creating and justifying and communicating and questioning and inferencing. Then when they leave my class, they go to Aram's class, teaching a totally different subject area. But they're also going to be questioning, inferring, and making justifications. Now, we're not teaching the same thing. That's fine. Because when the student walks out of there, they're not going to be a carpenter power engineer. That doesn't exist. They're not going to be a science social studies person. They're not going to be a chemist and a culinary arts person, although that does kind of exist. So you see the point? Sort of. So what is it that we want them to get out of this crazy process of shuffling them around from different areas to different areas? Higher order thinking skills extend beyond the school. So think of what those are in the first place. So inferences all came to you. You had to know, for example, you made inferences because you said, well, we're going to a prom, we're going to a party. It has to be formal. I didn't tell you it had to be formal. You made that inference. So you made a bow tie, made it look nice. There's other inferences that go with a bunch of other ones, and you can think about what that means. So those are kind of where that starts from, right? That's what I designed for. That's what I wanted the students to get out of this. As a sidebar to it, there were boring content standards that mix with it, which guess what grade level they're actually in now with the next generation science standards? Circuits. 5th grade. 5th grade. So it's challenging. So obviously, I'm not going to redo the whole 9th grade stuff because when they come to 9th grade, they still don't know it. So it's tough in that sense. But you're looking at content areas, you're looking at what standards you're hitting, and you're addressing those. Then what are the basic skills? They want to talk about, I want to teach them about safety a little bit. So short circuiting is an issue. Have them discuss that or learn that on their own. It's only 3 volts. It's kind of okay at this point. Wire cutting, how to use the tools for that, how do you read a meter with voltage, how to use a meter in the first place, and just general circuit design in terms of what each component does and where it goes in the circuit, because those skills are going to be used for the rest of the year. These skills and these abilities are going to be used for the rest of their lives. And then there's cross-cutting concepts, so anywhere you want to integrate it into other areas, science topics, algebra topics, point them out, and it always helps to guide some of your lessons as well. So 2 strategies that I'll show you that I use. If I want my students to ask questions and make inferences, right? That's my goal. What do I do? How do I design for that? One thing that I definitely do is I provide enough information that encourages them to build on previous knowledge and experience. If I know that they know something, I'll provide just enough to get them to the next place. So I said prom. That elicits the concept of formality and a bow tie. It's a basic example, but that's what I'm looking for. What I don't do is give them all the necessary information. How are they going to start asking questions and making inferences when I tell them exactly what they want and exactly how to do it? If I want to make sure that they're creating and redesigning, then I'm going to give them time to test and change their product, right? And maybe look at other people's products and give them a chance to go back. And then I'm not only going to give them one chance. I'm going to allow for that reiteration, just like life does in most cases except for tests. So basically, create your scenario that's realistic and relevant to them. Be as creative as possible yourself. Something that hides the learning, which I said to a few of you before. They thought they were making a rave stick, right? They didn't know that they were learning about circuits, or electricity for that matter. And something that inspires a challenge within themselves or within a bit of their peers, a little competition. Trust that students are capable, that they can make decisions, that they can find information, that they can find their own materials. As I said, don't provide stuff for them, that they can come up with their own ideas, and that they can determine what they should know, when they should know it, and who, what, when, why, where. Let them figure it out. And let them be prepared to guide you. So be prepared to guide them. One of the things that I didn't show you guys, but I always have on hand, are a list of questions, kind of like a facilitator's guide. And the questions actually go along with each one of the constraints that you guys had. So I can anticipate that you're not going to know what a series or a parallel circuit is beforehand, because I know that most people don't. So what questions would I ask to lead you into that direction? So when I said, how do we know it's 3 volts? How do you know that it's definitely 2.4 volts rather? Well, everybody thinks 1.5 plus 1.5 is 3, right? But what happens if you were to connect them differently? So I'm ready with those questions. I'm ready maybe with a demonstration. I'm anticipating that so I can guide them to get them to learn and to think and to ask questions, because I'm not giving them answers. I want them to ask questions. And I let them make mistakes. If they make a mistake, they learn from it. So how many people here didn't walk back and forth before they realized, oh, the LEDs are polarized, so I have to put the positive and the positive and the negative on the negative. If I just told you LEDs are polarized, the longer one is positive, the shorter one is negative, everybody would have gotten it right the first time. And expect to be amazed. I think most of us have been amazed by our students at one point in time. Expect to always be amazed, and you'll be amazed. I'm going to give you rubrics, group work. What does a good group work look like? What do 21st century skills look like? This is a very generic 21st century skills one. I give you more advanced ones if you want. I gave you a more advanced one for that 21st century skill of accessing and analyzing information. So it's broken down in very specific things that you would do. You can look at these now, or you can look at them later. They should be part of your design, I think, as you go through the design of your own project-based learning. And I'm going to give you a template as well. I used to, yeah, you want to hand those out? This is the template. It has questions and a little bit of information about what to put into it. I used to hand people a template and say, here's your template. And it was a blank page. And I used to see, can you design what you had here? And it was great because some people had a really good idea, but I find that a blank page is really challenging and not as easy as it looks. So you have a blank page, and you have a template as a guide. Allow you to choose your own. This is not, I'm not saying that I am the end-all, be-all in project-based learning. You might have a great idea as to how to design this, and you could put it here. But if you want some guidance, it's on the front or back, whichever way you want to look at it. The teachers are going to be engaged in designing their own project-based learning scenarios. In this format, they're actually going to be following a template that's provided for them. If you would like access to that template or to any of the other documents for that matter, you can check them out on the website, which will be posted at the end of this video. The main idea behind the template is that you keep the end in mind. So if the end is for the students to really have a firm understanding of the content, then you design a lesson based around that. And all of the pedagogy that goes along with that, all of the methods that you actually provide and implement during the class time should align with the outcome of having the students understand the content. If, however, you want to have a more well-rounded student and have a student who's going to be more capable in this diverse and ever-changing workforce, then you design for the higher learning skills such as collaboration, critical thinking, and creative thinking, and other 21st century skills. And to do that, you start asking yourself, well, how can you really define a lesson and guide the students towards those end goals? And the template asks you some questions that will assist you in developing a lesson or a project for that matter, such that the students will end up successfully achieving those outcomes in the end.
So the first thing I want to point out is that this process that we just went through is a great start. And everybody that was coming up with ideas, every single thing that I heard was pretty awesome. And I'm really happy because I think this is the first time that I feel like everybody in the group really comprehended what I was saying. And I appreciate that because there's a lot of times that it doesn't happen. So what happens next, right? Where do you go from here? You have a template. Do you want to keep using it? Do you know what each piece means? There's a lot of information out there on what an essential question is, why we have them, how to think about them, what you can do with them. All this stuff is out there on the internet for you. Grant Wiggins, like I said, came up with the template or a template similar to the one you're looking at. He has a lot of great stuff on it. I recommend you do that. What do you do in your classes? How do you continue to design like this? There's one thing that I think you should really, and just in life in general, just kind of always keep in mind, is that you don't know what they want. You can make as many assumptions as you can think of, but you really don't know what you want. So let me tell you a really good example. There's an Italian guy who made a lot of money and wanted to save the world. So he decides Africa needs saving. He goes to a country in Africa. He finds this village. He says, you guys have great soil. This is amazing. How come you're not healthy? You could grow so much food here. So he brings all of these plants and seeds out, and he starts planting away, and he's got all these beautiful tomato plants, and they're looking at it, and him and all the people that came to Africa that set it up, they're all celebrating the night before, and the people from Africa are just like, okay, whatever, shaking their heads. Next day, they wake up to this rumbling, this crazy noise. He thought it was an earthquake. They look outside. Rhinos came in and ate all of the food. They go to the Africans. Can't believe this happened. I'm so sorry about this, so sorry, like we'll do something about this. And they're like, what are you going to do? This happens all the time. Why do you think we don't grow stuff here? And they go, why didn't you tell us that? And they go, well, you didn't ask. So they thought they were going in, saving the world, growing food for these people. The Africans are looking at them like, look at these idiots. They're going to grow food, and the rhinoceros are going to come in and eat them all, right? So yeah, they got food. You fed the rhinos, so somebody ate. But point being is that you design something based on your own ideas, your own assumptions. This is what I think the students might like to do, right? Now, use that to get them to understand project-based learning, start dealing with some of the concerns that you're going to run into, and then allow them to design their projects. At some point, they should say, I'm pretty good at carpentry. This is what I want to make. Or I'm pretty good at HVAC. Here's what I can do. And don't just say yes to them. Submit a proposal, get their ideas, what steps you're going to take, what methods you're going to use, what safety you're going to have, who are you going to talk to about it when you're done, what are you going to do with it, where is it going to go, what materials do you need, how much is it going to cost. Ask them the same questions that you would ask anybody who's going to do that in real life. And then if you have all that stuff worked out and you can do it, say yes, right? Let them do what they want to do. So at some point in time, go with that. There's a company that I'll plug right now called Project Foundry. If you are a supervisor in a supervisor position, and the supervisor here already knows of it, you probably have more power than a teacher, but if you're a teacher and you want to do projects and you want to do them well, Project Foundry supplies a lot of great planning templates, and record keeping. So in other words, the students have access to their plans. They can go online and say, hey, here's a project, here's what I want to do, here's the standards I'm going to meet. They submit it to you electronically. You look at it, you say, hey, meet me at Tuesday at 3 o'clock, we'll talk about it. You sit down with them, you go through some stuff. Maybe you can fix a couple pieces here or there, and you give them some advice, and ultimately they end up with a good project. Then you let them go, and then they do it. And they keep track of their progress, and they check off, they provide their own feedback, and what you end up with is not a grade, but a spreadsheet of information. How creative were they? There's a pie chart, or there's a bar graph, there's something, whatever display you want to come up as, and it tells you what standards they're at, what they still need to work at, and what they've mastered. It's pretty impressive output. Slight learning curve, slight is a loose term. It's not that easy to use at first. It's a little bit more work, but once you get it, it's so powerful, it's amazing. So I want to go over real quick. I saw some people had some challenges. When you were designing, what were some challenges that you ran into? What were some problems that you faced? What were some things that you just didn't grasp when you had to put these ideas on paper?
I'm all over the page. I'm trying to focus in. Am I doing it for one small segment of my course, or am I looking at the whole big picture when I'm trying to figure out what I'm planning, and those major questions?
And you were even, so she even asked me, what do you want? What do you want? What do you want? She's a great student, right? Just like she said earlier, I'm doing this because this is what you told me to do. I don't want anything from you. What do you want out of your students? I'm not looking at your sheet. I'm helping you make whatever you want out of it. Your project can last 20 minutes like ours did, or a little more, or it could last for the next 5 years. It could last 6 years, 7 years. That's okay. Think long term. I was saying to a couple of groups, try not to do the same thing every year. Try to make what you did last year better. Try to do something different, okay? Any other challenges?
Connecting the content with the abstractness of what the project had to be.
And that's a challenge. That's
You know?
not easy.
Yeah.
So it's almost like how do you go with those higher level areas and then sneak that content into it?
Yeah.
And sometimes you might realize that they'll think of a better way to come up with other content that you didn't even think of. And is that okay? So if I want to teach them how to do Pythagorean theorem, and I want them to make a ramp, and that's my design challenge is make a ramp, and then the next thing you know, they're doing an elevator. It's like, oh, how do I teach them Pythagorean theorem now? You know, but that's okay, because there's other things that I can teach them through that, and they thought of it on their own. So coming up with the content, designing for the content, designing for the bigger picture, the more abstract stuff is challenging, and the content may get in at that point. If it doesn't, what can you do to facilitate it? What questions do you need to ask, and how do you need to guide them? And that's on the bottom, if you see that, it says, what are some potential rough spots? That's where those questions come in.
Actually, on the bottom, you have what if it's unsafe? That's just something Aaron and I were working on. How do you do, like, let's say, a lesson for a drill press or something like that? Because I'm really interested in, we could talk more about this, obviously, but I think it's very interesting to do the straight creativity instead of a step-by-step, but what about for unsafe materials? So that was something we were working on. We came up with like a broad concept for the first part of, desired results. Like we put in manipulating materials to a desired measurement with a mechanized, harder substance or energy, but then now you have to come up with a scenario like you go into a rave, so you got to cut a hole in something or something.
Right.
But it's challenging because you got to be creative.
It is challenging for that. So why do you want them to use a drill press, and how can you get them to want to use the drill press and then have them do? So there's two parts to that. I think it's unsafe to say, today we're going to learn about drill press safety, have the 25 students that are in your class stand around the one drill press. You got 20 kids doing absolutely nothing and something entirely different, and you got 2 kids that might have an understanding of what you're saying. Whereas if you say, here's a challenge, how can we solve that? And at some part, the only way that they can solve that challenge is if they drill a hole in something. Once that kid realizes, well, I know exactly what I want to do, here's what I want to do, and here's, like, I need to put a hole here. Okay, how are you going to put a hole there? I don't know. Come with me. Now that one kid or the two kids, they're sitting there and they're listening because they are not listening to you saying safety, 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 safety. They're listening to you say, here's how you solve that problem that you came to me and want to solve. And that's a difference. So they're going to listen to you and they're going to take that to heart, and they're probably going to be more safe, I hope.
I just want to say that I agree with what you're saying, because the idea is, oh, well, I'll demonstrate it. But it's true, if you got 25 kids around you, there's only a handful that are going to get it.
And
so
are they going to use the drill press as soon as you're done with the demonstration?
No,
or are they going to use it a week later, and you're going to say, why did you screw up? I have your safety sheet that said that you sat there and listened to me for 20 minutes while I was talking about safety, and there's my signature. I checked off on it. You know,
it doesn't mean anything.
Doesn't make as much sense to do it when they want to do it at that particular time. So. Anybody else with any challenges? This is not an easy process, right? And it shouldn't end here. I can't stress that enough. I wish that I could work with you, or you could all ask questions, or you could all develop your own ideas and continue on. But unfortunately, we have this whole summer that we have to enjoy. It just gets in the way of being able to write content and curriculum and develop projects. Bothers me. I don't know about you. Yeah, my buddy's forcing me to play golf tomorrow instead of writing, so I really want to do essential questions. But so last two questions. What are you going to do more of? You're in a classroom, you have this project-based design. What are you going to do more of?
Let the students do the discovery.
Let the students do discovery. So you're going to trust your students more. You're going to make them more of the process. You're going to give them more responsibility. You're going to encourage them to be capable. It's not an easy thing to do, right? Because you think about it, how many times do you just like, oh, here you go, here you go, here you go. You think that that's what you're there for.
I have to be honest, I'm leaning toward older students, not so much the younger ones.
Right.
Sometimes
Well, you
freshmen are
step
like
it up
sixth
little
graders.
by little, so yeah.
Yeah, and those of you that teach high school, some kids come in as freshmen, quite mature, and some are horrendous.
Yeah,
Absolutely.
I know. Not looking forward to freshmen this year.
I think I'm probably going to do a whole lot more telling them to just go figure it out.
Or asking them the right questions so
Yeah,
that way they
I
can
think
figure it out.
question
Right?
asking, I think, is really important. Yeah.
Right. Asking questions, I mean, it's interesting too, because you learn a lot more about the stuff that you're doing by asking the questions that you would ask to get to the answers. You know what I'm saying? Instead of just asking the questions that you know the defined answer to. How
See,
are they
this-
going to get to that?
This shoots down my whole approach, because I usually come in with a syllabus. This is what we're gonna do by then, this, that, and the other. I gotta change that a little, I got to tweak that a little bit. And
Well, you can have timelines and benchmarks, because that's good time management skills, right?
Yeah,
So it's not
but-
like you can say, okay, we're going to do this project, and I don't know when it's going to end, but
Right.
You
but
do wanna have that.
Right, or homework assignments. You know,
yeah.
and I can't,
Homework assignments they're tricky. I like them because it gets the kids thinking outside of school, but what are they really doing? Are they actually doing the work? Are they really thinking? So,
right.
yeah, second day challenges I find work better. So what was on the homework? Why did I give it to them to do at home? Why not just when they walk in the next day, hey, here's a challenge. If you actually understood what we were doing yesterday, you should be able to apply it right now in this particular example. And that gives you
Or
better
if you give them the
understanding.
ability to use their stuff, their phones, you might get a better response and
Right.
stuff like that. So, yeah, I gotta tweak that a little
Yeah,
bit.
yeah, it's going to take some
Actually,
change.
I
It's okay to
can't-
change, right?
I can't tell them to go away and figure it out.
No.
I can't.
No, you can't, but you can ask them the questions that will lead them towards the answers, right?
Tom, let me make a recommendation for this. What are you going to do more of? Tell people what you're doing, especially your administrators and your supervisors.
Yeah.
Because this is voluntary. Some may not even know you're here. Let them know what you're trying to do so that when they come into your classroom, they know to expect something different than what's traditional.
Yeah, and if you look at, again, the stuff that's based around this design, it's based on school culture design. So you're limiting yourself by not telling anybody else. If you tell people, hey, here's what I'm doing, not just supervisors, but your colleagues, your teachers, say, look, I want my kids to really start questioning things more. And I'm a carpentry teacher, and you're a math teacher. How can you get your kids to start questioning things more? what can we do together to make kids question things? And then as students come from one class and go to the next, and they're questioning, and they're learning how to question, they're learning how to communicate or make inferences. If you get on that same page of what are the key intellectual abilities, which is written about a lot, again, what are those? Can we all work together on them? And what do they look like? So that's why I gave you guys rubrics. What is creative thinking? I think creative thinking is this. They think creative thinking is that. They think creative thinking is something else. If everybody gets on the same page about it, you're going to design much better because you have a concrete, cohesive, collaborative effort as to what that actually means.
And I would even say too, I mean, many of those words, all the new evaluation plans that are going into place in September, I mean, these are Danielson words. That's the model we're using. So, you know, we've already seen what the rubric will be that will be evaluated on next year, and it has all of this stuff on it. But no one's defined them. So that's going to be critical to
Yeah,
go back and
just
say,
like
okay, we're all
rigor.
supposed to be doing this evaluating and whatever, but what does it look like for our building or our school? So that's a question I'm going to ask.
That
but
makes everyone so nervous.
this
Right.
really leads right into that, you know,
Right.
what they're going to evaluate us on. Are we doing this with our kids?
And what is good teaching?
Yeah.
Everybody could, there's a great book, Creating Innovators, and the author of that goes around and does a lot of professional development. He says the first thing he does is show a video of a teacher in a classroom. He says, who thinks that's good teaching? And you have a range. He said, grade that teacher. You have a range from A through F, and it's always like all over the place. A whole bunch of teachers watching a teacher, giving them different grades on how well they teach. We don't even have a defined understanding of what good teaching is, right? And we don't have a defined understanding of what rigor is or 21st century skills and exactly what that means.
I had a professor who once said that the teaching is innate. It's something that comes natural. That there are no textbooks that really teach teaching, okay? And you know, I always grew up believing that to be true. And I think everybody is probably a marvelous teacher in here in their own right.
Their own way, right.
So, you know, for people to be evaluating us on craziness and,
Yeah.
and there's no clarity or explanations.
And if you watched one day in my classroom, I would probably be fired if that was the wrong day. 'Cause I tend to be very sarcastic, and I'll screw with my kids, and I'll have fun with them in a way that people may not understand, you know?
Exactly.
So I'm not a teacher anymore, so I can say
Here,
it.
here.
So no, that's the mentality of it. It's like, well, I have to stop being a good teacher that's been really effective because they're watching me now.
Right, right.
So, and then again, but I know other people that are very much different than myself, but are very effective, wonderful teachers. Ron's energetic and crazy in the classroom, and
he's got
I'm
a
not.
hammer
I have a
in
very
his hand.
monotone voice, and I probably move my hands more today than I ever have in my life. So, so what will you do more of? What are you going to do less of? What are you going to do better? What changed today? Enjoy that as you drive home in this beautiful sunny day. And if you have any questions or anything,
Yeah, thank you.
here's my. Thank you.
So I hope you enjoyed this presentation and that you learned a lot, and hopefully you'll be able to gain some valuable experience over the next year as you implement it. All of the documents and any other information that was in this presentation is provided for you on the New Jersey Green Program of Study website, which is njgreenprogramofstudy.org. My email is also on the screen if you have any questions about any of it or have any desire to discuss matters farther or even seek advice, feel free to contact me. Thank you and good luck.